let's start. Welcome. This session is about infinite lists in Cascades. And my name is Kjellberg. So Per, like a pair of aces, if you're wondering. It's a Swedish name, so I'm from the Swedish office in Malmö. The image I've used here to represent me is from one of our sample applications called the Photo Bomber. And that's one thing that I do at BlackBerry, is that I create some of the sample applications for Cascades. And with me here today, I have...
Yeah, I'm Daniel Rivera. I work for a company called Macadamian. We're based out of Ottawa in Canada. We're a service company, and we create apps for people and for companies. Yeah, my picture, Per here said, oh, we all put the picture of us with the Photo Bomber app, so you should do the same. Okay, and I did it. And if you want that app, it's on the sample site. And what it does is you take a picture of yourself, and it puts a random animal or face or something on it. And that, like, I got the bird too. It was the best one. The other ones would put a cow on my face, and I was like, no, I'm not taking that one. So yeah, that's the story behind the picture.
Right. So why infinite, and what do we mean by infinite lists? The whole problem that we're going to discuss today is, I have an example here showing the Twitter profile of Research in Motion. And Twitter is connected via network. You download data, and you can't download all the data. Then you will get a lot of data. So what you do is that you download chunks. You connect to the network, and when you get to the end of the list, you make sure to request more data, and then you fill up as you go. And this is the problem that we're going to address today.
Yeah, and
it's
not limited to Twitter, right? There's all sorts of applications that do this. More and more what we're seeing is things about big data, and there's tons of data out there, and all our mobile devices need to consume that and show that somehow, and obviously you can't show it all in one shot. So, a bit of background on why we decided to make a whole session about this. It seems like a simple problem. Question to the audience, have any of you ever tried to implement this solution to this problem? Yeah? Did you have fun? It's, you know, in short, it's really harder than you think. It seems simple, but there's a lot of things to think about. There's like edge cases and error scenarios and managing how much data you're getting, and is there a maximum, all sorts of things like that. And it'll seem simple after we've gone through the presentation, but I mean, this still takes a few days to implement at least. And the reason this was my idea, I submitted this to BlackBerry for a JAM session, was that I was working on a few apps at work, and the customers asked us to implement it on all the lists of a project. And having it, you know, done it before, I knew that the very first thing I had to do was to figure out how to detect when the end of the list is reached, like the list view itself. And at the time, this was about 2 months ago, before the release, there is that event that fires when you scroll all the way to the end. That wasn't there before. So there was a bit of wizardry involved in detecting the end of the list. But now they fixed that. They added that event, that signal, and like it kind of invalidated our session. But in the end, we found that, like we discussed, and it was still a worthy subject because there is tons of things to consider, and I think we'll hopefully be able to help you out if you you know, to teach you how to do it. And yeah, it's still a worthy topic.
So the agenda of today is like we have created a sample app and a server, so we can create this scenario where you actually download from a server, and we will rebuild this step by step, adding piece by piece. So we start with like an overview of ListViews, and then how to add a model, how to access the network data, how to add more data, what to do when something goes wrong. And then there are some few edge cases that we take care of as well. I think that's it.
Yeah, that's it. Next.
So we start with a little demo of the sample application that forms the basis of our presentation here. And there is a sample application for Cascades called the Weather Guesser. We modeled that and made it into a historical data instead. So we have a server delivering historical data. You should open the last one, I think, to see.
Oh, yeah. OK. So we have this is the completed project. So what you're seeing is these items, the data for them are grabbed from the server. And when you get to the end, it loads more, right? And we can also browse for other cities. What we were seeing is our home city. We set London as the home city. I'm not from London, in case you didn't guess. So you can, I'm from Ottawa. Look at the weather in Ottawa. By the way, the data is not real. Actually, it does get to 40 below. That's quite common. So it's not too far off. Anything else that you want to show in this?
No, I think it's OK.
That's the premise.
That's the basic app that we're going to create.
OK.
So back to the presentation. You need to switch.
Yeah.
So the first thing that you need to do is, you had to add a list. So you need to start with something. And the list view, in this case, we use QML to create it. So to populate the list with something, you need a model. So you need data for your list, or else nothing will be shown. And what happens when you connect the model to the list view, it wants to create items. And if you don't specify anything, it will create standard list items for you and try to populate them. But to get this nice-looking images that we have here, you need to set up list item components. So list item components are kind of templates for different types of item. And for different types, you can have different visual look of your items. So the model will tell the list which list item component it needs, and it will be delivered to the list view and populated with data from the model. So the first step that I'm going to show you now is just how to do that in XML. So I have QNX running here. And we have a lot of other QML files around this. We will focus on the weather page list and the model delivering data for that. So this is the weather page, which is now empty. And to the right, you see the preview. So the first thing I do is adding a list view to this page. But I also need a data model. So I say that I add a data model, and it will be an XML data model to start with. So I set the source on my data model. So I have a source, models, which is one step down, and it's weather.xml. It looks like this. So it's just a few items with data set in it. As you see, something appeared in the preview. This is now the list view trying to present. It's using the standard list items, but I want something else. So I will add a list item component. So I say if the type is item, if you look on the model here, item, then I will use the weather item. So as you see, we come prepared. There is already a set up QML for a weather item that has an image and so this is the weather item. It has a background image view and a label presenting the temperatures.
So in other words, what the list item component is, it's a template for what you're to tell the list view what the items from your model that have a type item are going to look like. So every time one of them gets loaded, it uses that weather item QML file that we have. So show demo?
Yeah, that's it for that part.
So that's it. It's running. That's what it gives you right after we add that code.
But we don't get very far with XML model in this case. That's mostly for prototyping the list view, the first step that we do, making sure that we get a good-looking list item. We need to address the data models. Yeah, you might recognize Lieutenant Data here.
Commander data.
Commander Data, sorry. Right, so here's the data model here. And the data model API, so we will now move over to handling our models in C++ instead. So the basic data model API has a number of functions, child count, has children, item type, and data. You don't need to implement all of these in all cases, as you will see shortly. But I want to mention that, so we've seen the XML model. There are a few other types. So there is an array data model, which inherits this data model. There is a group data model, which has the possibility to sort things for you. So it's a great, if you have proper data, will give you sorting on dates or strings already in a very easy fashion. But we need something flexible for our use case. So we will use the QList data model, which is a data model that takes variant types, so basically any type of item type. You want to add something to this?
No. That's good.
It's okay. All right. So then we go back to the code. And I will use the source tree to show you our commits and take you through them step by step. So this was the first thing that I did. Now there is a little bit more here, but what you see, the list view was added with an XML data source. And then we add a QList data model. And we do a few more things. So we need to now also bind the list view to something that's created in C++. So I expose the data model of the weather list here from my weather page to main.qml.
Okay, so just to recap, the weather page is the definition for that full page that you saw with the list in it. The list view component that's in that QML file has an ID, which is weather list. So what we're exposing is the weather list's data model, which is a member of the list view class.
Right.
Sorry.
It's fine. Go ahead. Jump in anytime. I just wanted to show you that here is where now we're in the main QML file. This is where we place the weather page in the UI in a tabbed frame. You don't see the whole code here, but so we bind it to this underscore home model, and this is something that we create in C++. Let me have a look here if there's. Oh yeah, we also added now code for handling which city is home city. Yeah. It's not something that we need to go into now. And we also added a few settings to remember the home sitting. But here we have function calls to create the weather model and create the home model. So we have a home page, the first page that opens up, and then we have other pages presenting weather. So if you look here now on create weather model, we just create a new weather model, and then we expose it to QML using this underscore weather model. Then you can attach it to the list.
That's the convention, right? When you're exposing something, that's what we are using now. Okay, so underscore something means it's some object that you bound from C++ that you make available in QML.
Right, and now we also added the weather model.h files here. I guess the most important things are, if you look on the class, it inherits weather list model, which is a
QList data model.
QList data model, it's up here, yeah, and it takes variants as its type. And if you look on the C++ file, it's now just a dummy model, so there's a creator. There is a function called item type, so the list view will ask the model, what type of item did you just deliver? And we reply all the time, item, it's the item. And then we have a function which adds data to the model, and I just added 2 dummy Q-variant maps here to get something in there. That's the first step. Now, down here, you can set the city, and this is where, when you change the city, you change the data. So you clear the model, you update the city property, and you tell that the city has changed, and then you request the data for that city.
Okay.
That's it.
So just to prove to you that it's real and it works, we have, see, just the 2 items that we added, they're here. And did you do this for all the cities? No, it's empty.
No.
Okay, well. Okay. Oops.
Right. So now it's dummy data in the model, but we want to access something from a server. And to do that, we use the Q Network Access Manager, which is a Qt object that can communicate over the network and delivers data to you in a slot callback function.
Is that my slide?
Yeah.
Oh, okay. For our server, we have, so okay, well, we're adding the Q Network Access Manager. We now need a server that delivers that data. So what we did is we created, using Java, a web server, using the JAX RS Jersey something framework. I forget what it's called. But essentially, it's, I'll show you in a second what the code looks like. But essentially, what we created is a server that runs on whatever port you tell it to on a machine. We're running it from this Mac right here. And it gives us a number of resources that when you query that, it'll just return JSON data. We have regions that gives us the list of regions that are available, that we have data for. Then regions, if you drill down to regions / the name of the region that you previously obtained, it'll give you, I think, the list of cities for that. You can get a full list of cities. You can get cities, regions, city, and that will give you actually the weather entries for that particular city. One thing to note is that it has a start parameter that you can provide, a size parameter that to tell the service to give you 10 items or 100 or whatever. There's a problems parameter. That's actually a little trick that we put in to tell the server to take its time or generate random errors. We do that for testing. And understand, okay, so those are the URL. I'll hide it. That's the service that we created. It has all these paths, and now our Q Network Access Manager is going to query those things. What's really important when you're working with a remote server is to understand the responses and all the cases, all the scenarios, all the errors that it can give you. And they all work a bit differently. Where I had to implement it in the apps that I was asked to implement it on, it really, like, I had to go through the documentation a couple of times and try to understand it because it didn't make sense to me. For this presentation, the server we created will give us errors such as 500 internal server error at any time. It could give us that. It could tell us 503 busy. That means it's busy and you should come back later, but it's not dead. It's just come back later. It can give you partial result sets. You never know if a server is going to give you the full result set. So because I have a size parameter there, I can tell it, give me 100 items. But if it's too busy, some services decide, oh, I'll just give you 50 back right now and ask for more later. It also returns 404 not found if a city is not there, or if you are asking for an index that is out of bounds. And if there's no data, it'll just return an empty array.
Right. JSON. No. JSON data access. That's what you get back from the service. So you get the data. You use this way of preparing an URL to request something from the data from the server, and what you get back is JSON formatted data in our case. And to handle that and connect and deliver that to the model, we use the JSON data access, which is an API in Cascades. So I think next up is just showing a little bit on what that entails. So we go to step 3, adding loaded data. No, we did. Yes, we do. So okay, so we start in the weather page QML here now. You see that we've added an activity indicator. So while we are waiting for data to arrive, we need to do something, or the user will get very frustrated. So we show an activity indicator. So there will be something spinning on the screen while we wait. And you see down here, the running property is connected to a property of the weather list data model called initial load. So this will only be showed while we are waiting for the first batch of data to arrive. And we connect some signals here. Oh, this is just if we get a reset, we want to reset the data model. Not so important in this case. Let's go here. So the weather model, now we added a JSON data access, as you see for the includes here, and the Q network access manager. So if we scroll further down, let's see if we can find the good stuff. Here is where I had my dummy items before. You see they are now removed. And instead, I set up a path for a request. And we actually have a helper function doing that for us. So I check which city is set on the model and which region. So is it London and Europe? And I request a path for that. And I also add which index it should start from. So in this case, now it's 0. And then I have my Q network access manager, and I ask to get this data that's in this path. And finally, I connect this reply that's created to a slot function called HTTP TP finished. So once the reply is there, this function will be called. Up here. So obviously, I need to check if there was an error in the reply. So if there is no error, I use the JSON data access object here to load the data from my reply as a Q variant list. So now I have a list of Q variants, which is very appropriate since my model is set up to handle a list of Q variants. Then I check for errors.
Yeah, there
could be an error in when reading the JSON data.
Parsing it, something.
Parsing it. If there is no error, I set 200. And I can scroll down a little bit here, and you see in 200, I make a call to a helper function to load the actual data into the model. So that's the last thing I would do.
Right, because right now, all we did is receive some data from the network, and now we're going to add it to ourselves, which is the class, right? The data model.
Right. So this is the function that actually does that. We do a little preparation of the date, because we receive the date as a string, but in this case it's convenient to have it as a Q date. So we transform each date string into a Q date instead and insert it back into the item map at that position. Once that's done, we just append the data, and now it's in the model, and we see it in the list.
And this is an example of it working. And we got, I don't know how many items back, but that's it.
20.
20?
Should be.
Okay. So.
We will have questions at the end, if that's okay. Just so you know. Try to remember them.
Okay, detecting the end of the list now that we have data from the network. We're number 4. Okay. So that's where the fun begins. How do you detect the end of the list? I mentioned it earlier that there is a neat little thing called the list scroll state handler that fires a signal that is called at end reached or something, and we'll see that in a second in the code. And in the past, this was a bit tricky because that wasn't there. So what you did is you remember what we just saw a function in the data model. It was called item type, I believe. That's when Cascades asks you, okay, the item at whatever index, what type is it? Let me know. And what we would do is we'd check internally, like, okay, is Cascades asking me for the last item? And in that case, we would say, okay, he's asking for the end of the list. It wasn't always good because Cascades pre-caches some items, and sometimes it'll ask for like the next 20 items. So it would work. Like it didn't matter because you would see actually, you wouldn't see the end of the list because it always had more items unless you'd scrolled really, really fast. But now there's this convenient way of doing it, so you don't have to make that hack anymore. Did I say trigger, load? Yeah, good. Do you want to show the code?
Oh yeah, it's just a small addition to, let's see, how do I get a bit more lines here? Oh yeah. So we are now in the weather page. So here is the list view, and this data model is overridden now, the XML data model, by the property that we set earlier. And the only thing I added is the list scroll state handler. So you see now I'm listening for the on at changed end. And when I get the at end, it's time to request more data.
Yeah, there's a bool var there. It actually tells you when you leave the end. Is that right?
Right.
Yeah, when you scroll back up, it tells you, okay, we're not at the end anymore.
Yeah, exactly.
Okay.
So
that's it? You make the request? Oh, you're not making a request.
Back to the presentation.
Okay. PC. That's your slide.
So we need to get more data now. We only know that we're at the end. We didn't do anything. So we need to make a new network request for more data. To do that, depending on how your server works, but in most cases you also need to tell like the offset of your data. So I need more data, but which data do I need? So you need to keep track of the index of your data. So I'll show you a little bit of that. So now I added a call here to get more data. And as you see, it's the weather list data model, which is where I make the function called request more data from network. You might recall this name. You have seen it before. And the reason I can call it directly from QML is because I made a function QInvocable. So then I can access it from QML. And what I do is, I probably added something more here at the end. Sorry, yeah, I should show you this as well. We also introduced a data cursor. So now for keeping track of which index we need, we inserted a data cursor that starts at 0. So where do I go next?
Just show the code.
Right, so here we have the set city. When you set a new city, the initial load moment, we create a new data cursor. And I need more lines of code here today.
No, actually, it's because the function request more data was already there.
Yeah.
So now it just gets called more often. And the only thing you changed in that function was to when HTTP, I pressed the power button. When the HTTP finished returns with data, we have a number of items there. We might have gotten 10, 15, whatever. So what we do is increment the cursor index.
We also did modify the call to the server a little bit, adding the offset index so that we get the correct data so we can add more data. Right.
Okay. Okay, stopping. So eventually, I want to show the demo first. Yeah. Cool. So that's after adding that code. When you reach the end.
Is it the right one?
Probably not.
No.
Do you have the number? It's 5?
It's 5.
Okay. So now I reach the end. Yeah, there you go. Poof, it just adds more data. See? And poof, more data.
You can just keep going and going.
Yeah, you can go forever. Until the server craps out. The PC. All right, so as I was saying, eventually you need to stop because that just makes no sense to go on forever. So how do you detect the end of the data reached? As I said at the beginning, you have to know your server well and read the documents. In our case, we created our own server, so we implemented what made the most sense, and that was return a 404 error when you ask for an index that's out of bounds. And can we really rely on it? In our case, yes, that's what I'm saying. If not, in the case where I had to implement it on my real-world applications, I couldn't. So what we did is we kept track of the total. So every time the server gave us a response, it would include the total items. So we just checked against how many items we had against the total, and if we had reached the total, we would stop.
Okay. So what we did is in our cursor, we now introduced a Boolean that keeps track if the end of data has been reached. So that's something that we set when we noticed this. And when we get the finished data delivered, we check if it was an error. And as Dan said, our server will deliver an error when we reach the end of the data. So we parse the status code of that, and then we add a check down here. If it's 404, we just set that the end of data has been reached. That will then we'll stop making more requests. And it won't be possible even if we try to call for more data. And we do this by controlling the request for more data from network function, where we check this cursor.
I won't show you the demo because our server has too much data.
You won't reach the end.
No. Well, I mean, there's like 1 million entries. Okay, it would be interesting. I don't know. Okay, maybe I should show the demo. Just before I showed you that, it would reach the end and poof, items would appear magically. It would be interesting to have this item that you see at the bottom there loading, just to tell the user what's going on.
Especially if you have a busy server that's not delivering to the user, it might become frustrating that what's going on. Is it the end? Do I have more of this, like RSS feed or whatever it is? Mm-hmm. Or is it really stopped? So we need to add something UI-wise to tell the user that we are busy. We are trying to get more stuff for you. So we'll add a loading item. And I will show you how that's done. So first up here you have a new QML file. It's the loading item. I won't go into the details, but you see a container. And here you have an activity indicator. You remember there was something spinning there. And here you have loading label. We use, what's it called? The rich text format, so the HTML way of setting the correct color of the text. Right, so there it is. But I also need to now to add it to my list item components. So now I have another type. So I have another template. It's not just the weather item anymore. It's also the weather load item. And as you see, the type is different now. So it's a load item. If it's a load item, that will be shown. If it's an item, this will be shown. Then in the weather model, I added a couple of functions. So one is insert load item, and one is remove load item. And I will show you how I use these. This is what happens now. So we ask for data. The data comes back. We want to give it to the model. We do that in load network in this function here. So the first thing we would do is try to remove the load item if there is one. So if there is a load item already, we remove it. And then we add the new data. And then at the end, we insert a load item. And the way we create the load item...
And the load item is always present. You just don't know it, right? Yeah. It's always at the end of the list unless there's no more data, where we have scenarios, I think, where we're not adding it. But yeah, it's always there. It's just lingering there at the end.
Yeah. So the way I set up the the load item for the model is just creating a Q-variant map and setting one of its keys to load item equals true. So now when I get calls to the item type, I can check, am I at the end of the list? Does the data that I get, does it contain the load item? If yes, then I return load item, and then it will be displayed a load item at the end.
Good?
Yep.
So this is the load item at work. Oh, no,
Or
wrong.
is it? Oh, yeah, no, wrong one.
Which one is it again?
7.
7. You sure?
I hope so. Yeah,
Yeah.
there you have it.
See, it's there. And like I said, it's kind of fake. Like it's always there. It's just to show it when you reach the end, it's there, and it's immediately visible by the user. And it's funny. Funny anecdote. When I was implementing this on the apps that I for my customer, there was a bug once, and the QA person came to me and said, "Oh, like it's not working. It's never returning from loading. But I see the loading item there, and I know it's doing something." I'm like, "No, I implemented that. It's fake. It's just showing you something, but you don't know what's going on in the back." So, it's faked.
Well, it's
Kind of fake, but it's not representative of what the network manager is doing, right? So. Back to the demo? No, PC. Sorry.
no to the presentation.
Yeah,
Yeah.
it's called PC.
Okay.
Okay, so now that we can get more data, let's do some error handling. What could go wrong? Like I said at the beginning, no connection. What's that? Oh, it's just when it craps out. Yeah, when the network manager craps out. Timeout, it could just take forever and you'll never get a response. There's server errors like the 500 internal error or all sorts of codes. Server busy, could be busy. It could be an invalid city that the server doesn't have, but we have obtained somehow or tried to reach. And it's really, like, we'll show you code for that, and the way we bubble those errors up to the user is really, it was up to us, we made the requirements, but in some cases you will want to handle it differently, you'll want to display, like you have to ask yourself, like, should I switch off the whole page and lock the app, or if the server's busy, what should I do? Should I just wait and try again later? And there's all sorts of scenarios like this that you'll need to think about.
So we start at the all too familiar weatherpage.qml. What we've added now is a new property error that we bind to an error code in the data model. We'll get back to that. That gives us the possibility. Oh yeah, I messed up this commit, so I will go back to Momentix and show you this because it's easier to see there. Hold on to your hats. So there you have the error variable, and as soon as that change, that will trigger a signal in the onErrorChanged signal handler, and it will deliver the new error code. So we check which error is it. We have a number of them, or it might be none or undefined. Then we just don't show the error page, which we have down here. Otherwise, we set an error message to give the user some idea of what's going on. And we also added this control here, error message, that we display when there is an error. And this is a custom component error message that we built in QML. Whoa. One thing that we need to do in order to use these enums that we will set up, that we read in the QML, is that we have to register the weather model that contains these enums as an uncreatable type, just to be able to use them in QML. So if we look in the weather data model now, we have added some enums for the weather model error. And we added a number of errors here. And there's the property as well. So what happens when we get an error then? Let's see. Here you go. In this function before, we only had the 200, everything is fine. And then we added the 404 for the case when we asked for an index out of bounds, which is kind of an error that we've already taken care of. But now we have more error codes. So if we get the 503, for example, we set the error code, and then we break. So let's go and see what this function does, set error code, if we use server BC. So what I do is that I update my internal class member variable, and then I emit that the error code has changed. That will now make a signal appear in QML, and I can display the error message.
That's
it,
I
think.
Okay, let's show that in action. So,
have you turned on the errors?
No, we have a problematic city, you know that.
Yeah.
So that works. No errors. We have a city here that on our server we're not handling the accents properly. Well, that character. So our server craps out on this, and this is what happens. This is good. Supposed to be. Okay. And São Paulo is bad. And actually, we can try. In our settings, like I said, we have, the simulate is on. Does that work? Remember at the beginning I said our service has a parameter that you can set, which is problems, and problems please. That gives you problems once in a while. So if you scroll down to the end a couple of times, eventually 1 out of 10 times it'll give you an error, but it's too loud. All right, so that takes pretty much care of the standard stuff that you need to worry about. However, there are these edge cases that we want to handle. What if there's no data for a city, in which case you would get an empty JSON array from your server, and you want to handle that somehow in your UI, or else you're just going to get an empty list with a black screen. Do we even handle that? I don't know. Maximum number of items. Obviously, you can't just continue on forever. So you will want to have some ultimate limit in your code where if you reach that, you want to stop in whatever case, even if there's more data on the server.
What is reasonable limit for? What is reasonable limit for
So
such
yeah.
list?
So the question is, what's the reasonable limit for such list? I have no idea. I've seen 10,000 items and it was fine. Okay.
Yeah.
But
the UI will put some requirements. I mean, 10,000 items is really.
But actually, it just keeps
then
20 or 40 cached, right?
Yeah, right.
But then
Still, the model might contain.
The model is still
So
occupying
when
memory, right?
Then you would have to do some tricks to have that memory overhead to
That's right.
have some ghost items or something. But also UI-wise, it might not make sense to have that many items. So you might want to think about a different way of showing your data with a filter or something like that. So because a lot of scrolling otherwise.
Yeah, it's a lot of scrolling. Oops, sorry. Tweaking, you can. So we said that how many items are we fetching? 20 or something. And
20.
We're fetching in chunks of 20. We want to adjust that. Sorry, we want to make that adjustable. And also, I think that should be included in there for the code where the scenario where the server doesn't give you as many items as you requested. The simple way to handle that is that cursor where we track the index of where we're asking data. So when you get data back from the network, you want to increment your cursor by only the amount of items you got, obviously. And then there's the one item problem that we didn't mention. So, okay, I just introduced this problem where the server could give you back less items. I've seen cases where it would give you only one item back. And in that initial fetch, what happens is if you get just one item back and you add it to your list, the event, the scrolling event, never gets fired. So you have that one item there and the loading item, and it just waits forever. Okay? In my opinion, it should tell you that it's the end, but that's not implemented yet. So we actually had to go back to the old method that I told you about, where if the Cascades asks you for the last item, you go and fetch more items until it stops. Demo.
So we introduced a couple of parameters to tweak the max size to see if that we can handle that correctly, and we also introduced a load size so we can change the chunk, how many items we actually get. And then there is this hack threshold. This is the problem that Dan just mentioned, that how many items should we actually wait for and do this trick until we can rely on the event that we need. And that might depend on how big your items is. So it's not, there is not a real, like, this is the answer.
Yeah.
Because if you have like a few items, large items, they are like...
Well, so if you look at these large items, oh no, okay. You know this large item that you see like this? When you would flip it on the side before, it would keep the big item, and it would take like almost a whole screen. So one item was okay because it actually went over the screen, and you had to scroll to get more.
Right.
But when you have smaller items, it's a problem, right?
So let's show you that first, how to handle that. Let's go to the item type. So now we added a bit of code here. It's always nice to have these comments in your code, right? Hack. Well.
So when Cascades asks us for an item type, and again, that's either the load item or the item type, we called that limit, that minimum number of items, we called it the hack threshold. So until Cascades has, we fetched that minimum amount, we'll just fetch while it's asking for that item. So that's what code is.
Right. We also added ways of keeping track if we have reached the maximum number, and if we have, we will set the cursor to end of data to true, so we stop asking if we have this limit that we have set. Is there anything else you want to show in this?
Did you show all the files?
I will. In the settings page, we added functionality for...
No, I'll show the demo. So, okay, that's the app, and the settings now have these things, and I can show you. So I can tune the load chunk size to 1, and it will do this behavior now. It just loads 1, and 1 more, and 1 more, and 1 more. And look at it go on. See, that hack threshold that I told you about is working now, because I'm fetching one item. I'm forcing it to fetch one item at a time. We actually have that just for the scenarios where the service gives me one, because I'll always ask more than one. It makes no sense to ask for one item. And see, it just realizes that, oops, I didn't fill the item yet. But that, again, like Per said, that really depends on the size of your items. Because if you have very short items, you might need to fill 10 at least to go over bounds. Our items are huge, so it doesn't, just 2 is enough. Okay.
Right, so just a few words. So we showed you the list view in QML. Maybe I can use this one. Mm-hmm. Sometimes you want to do implement the list in C++ instead. And this is just a little bit to tell you the background. So you have the same way of looking at it In C++, you also have a model. You have the same model now, obviously, and the list view is in C++.
Didn't we just look at a bunch of C++?
Yeah, we did look at a bunch of C++.
What's the difference?
This is if
the components.
Maybe you want to move into C++, and list item components are not available. So this templating of the list item is not done the same way anymore. Instead, you have a list item provider. So that's a class an interface that you implement, and the functions that you have to handle is the create item. So that's where you create an item for the list of a specific type. So there you get the type. The model still tells you the type, so you can do the correct one. And then you have update item, which is where you update the data of the item, because Cascades is clever. It's trying not to create a new item all the time. It's reusing items if they are of the same type. So then you just need to update the data. And then it's inserted into the list. Otherwise, it's the same thing. You need to attach listen for the end of the list signal, and you need to implement a trick, but that's done in the model, so you're fine. So it's just doing the same thing for C++. Mm-hmm. No code for that, sorry. So now just a quick summary. We talked about the list view, how it was done. Talked a little bit about different data models and that there are different types of them. Then we showed you how to download data from the first batch of data and more data, and also handling the errors if
and
you get them.
cases.
And the edge cases. Should we go this? Or
Yeah, do that.
Go to questions, maybe?
No, do that. We have time.
Yeah, okay.
Okay, other things to consider. In this sample, we didn't show you pull to refresh. What happens? Should you reset your data? How many items should you get? You'll need to think about that if you have that functionality.
And pull to refresh is, you have seen this at the top of the list. If you drag down, you want to add more new data at the top instead of at the bottom.
Thanks. What happens if the data changes on your server? We completely disregarded that. And because we should have implemented it because we have a history service. So if we open this app today and tomorrow there's a new entry that should go above the first one that you see, we didn't consider that at all, but you'll have to think about it. Making sure all the data gets loaded, that's actually, it seemed easy here, and it's really easy because we have dates, so we can just see if all the dates are sequential. But in the case where I had to implement it, it was really hard. Like, we didn't have access to anything to validate if what we were showing was correct. And even other implementations, we were copying like an iPhone version or an Android version. Each of the clients have their own way of filtering the data. So the service would give us all sorts of items, and the customer was saying, no, don't display these items. They're not necessary. But in some implementations, in some clients, it was. And then we really had nothing to check against, and it was just like we had to look at the raw data that the service was giving us, and it was quite tricky. Debugging the one item issue that we mentioned, that's a bit tough, but now I think we covered pretty much. Just copy paste our solution, that should work. We've debugged it enough. Understand your server, again, I keep mentioning it, but really read the documentation, ask all sorts of questions, make sure that you know how it will behave, or else you'll get, I didn't show this, but when I added the error screen, I wanted to go back and show you what happens when you get an error and you didn't have that code. Well, it just shows the loading item forever or a blank screen, and that's really annoying. It's a lot more complicated in the real world. That was a very simple scenario implementation. We put all of our code to fetch from the network and do all sorts of things. We put all of that in the data model. If you have decent programmer, you're going to split your logic into a few files, and you have to pass some information around, so you won't necessarily be able to take our sample app and just apply it to your app.
Right.
That's it. Good.
So any questions? There is a mic here that we can talk to. Anyone? Yeah, And there's one over there.
If it's a cute question, we don't want it.
No.
Why do you actually expect the server to return less than the limit you requested, even if it has more data than that? Is it because of computing requirements?
I don't know. Where the server I worked with, from when I had to implement it, just did that. And the customer said, yeah, sometimes it does that. And I was like, okay, I have to handle that.
You get like a CPU quota or something?
Yeah, probably. I don't know what it was. Instead of, I would have expected it to tell me that it was busy and just try again later. But no, it would decide. It was probably, like you said, a CPU quota, some cloud service or something. And it would just return half the items. And I think it's just like we need to protect ourselves when we develop code against a server. And that was one of the cases that we said, well, it's better to put it than, even if it gives you all the items, maybe someday you won't get it, and at least it's bulletproof this way.
In most cases, you just request 20 items.
Yeah,
you must 16, and you're like, that's it.
No,
end of the list.
No, we keep going until we know that there's no more. But yeah, I think it's proper to. It's a better idea to handle it. Okay.
Was there one more? Yeah.
I was wondering if in the list you have to also download images, then it gets a bit more complicated. You know, if BlackBerry platform has a facility for handling the download the image and the caching, or maybe a third-party framework to make it easier, or we have to do it ourselves.
No, there's. I looked at the roadmap, and there is a way forward now that the images delivered from the network should also be simple to handle. Yeah.
Do you know when more or less? Or
I don't remember. There was like on the developer side, that was shown on the keynote. I saw it in the flight chart there.
Okay,
so there you can see which release if you go to the developer side.
Thank you.
Otherwise, it's a bit complicated now that you have to handle that as well yourself. But there is a sample showing that as well. It's called TLDR, Too Long Didn't Read. It's a sample application of an RSS feed. So, and that one shows you how to download images and create your own cache of the images.
So the event you mentioned about when you reach the end of the list, so will that event be fired multiple times if you just scroll around near the end of the list?
No, I think just, maybe.
If you go down, it fires, and then if you go up, scroll out and back again, it will fire again. So you have to protect yourself against that scenario as well. Yeah. If there is a reply queued up, you don't make another request already queued up. You don't.
Our request data function has a flag there. It checks if it's already doing stuff. Not that guy.
I want to ask a cute question. Memory management.
Right.
You keep scrolling and scrolling and scrolling. Memory fills up. How do you handle that?
Right. So one of the things is that Cascades itself takes care of the visual things, so we don't fill up with data over there. But then in the model, if you have really heavy data model items, you want to start thinking about not keeping all the items, full items. But it's tricky because then you want to, if you see that your model data gets too big, then you want to have to throw them out at the top and load at the bottom. But then you need to keep track, so you add in more at the top again when you get back.
Mm-hmm. There's no support in the view for that, because it sounds like something common.
Yeah, well, there's no support, but I think you have to have a lot of items in there.
Well, like I said, I tried. I had 10,000 or 15,000, and it was fine.
Yeah.
It seemed fine. But that's a good question.
Yeah.
And something to think about when you're coding. Anything else?
That's it, I think. So,
No, thanks.
you can take that afterwards.
All right, thanks everyone.